Okay. Let's learn normal distributions. Normal distributions. And z-scores. Okay. We have what's called a bell curve. It's okay. We have what's called a bell curve. A bell, B-E-L-L. I guess it looks like a bell. It's a bell curve. Now, your average is at the center. And then the idea is we're going to have a very small percentage of people that get very high results, and we have a very small percentage of people that get very low results. Now we can capture 68% of the data, 68% of the data if we did one standard deviation away from the mean in either way. So one standard deviation to the left and one standard deviation to the right captures 68% of the data. 95% of the data is captured if we went 2 standard deviations away. And then 3 standard deviations away. So this would be, what did I say? 95%. 95%. And then if you had 3 standard deviations away, it captures actually 99.7% of the data. And then whatever's left, like those top and the bottom are obviously going to be 0.3% left. Tiana, any questions?
No.
No?
These are like the percentages are not, it's not accurate, it's like not.
No, it's pretty accurate if it's normally distributed.
Okay. Yeah.
So the data has to be normally distributed for it to be like this in the first place, which they occur, not always, but they do occur. So like maybe your exams can be normally distributed because there's a few students that are down here, a few students that are up here, and then the majority are in the middle. Okay, and like I said, the whole thing from here to here is 100%. Okay. Now the questions that you're going to more likely see are going to ask you, I don't know, let's say if we're at the center here, it's going to ask you, well, let's pick a number. It's just easier. Let's say the average was 20 and let's say standard deviation was 3. Okay, so obviously what number goes in the middle? 20. And then what number goes right after that? 23, 26, 29, 17, 14, and 11. Tiana, what do you reckon? Any questions there?
No.
If I asked you, I want to know how many people got in between 17 and 23. What percentage is that? 68%. If I asked you how many students got between 17 and 20? 34%. Yeah, awesome. If I asked you how many students got between or got less than 20? Less than 20. Well, that would just be 50%, right?
Oh yeah.
Because that's right in the middle.
Yeah.
Right, Tiana?
Yeah.
That'll be 50%. Okay, what else? What if I asked you how many people got in here? Well, there's a few ways of doing this. You could have done 50%, which is the whole thing, 50%. And then you could have worked out what this is, and then you could have subtracted the 2. What else could you have done? You could have also done like this. You know from here to here is 95%. You know from here to here is 68%. You could have done 95, take away 68, and then divided it by, nope, sorry, 95 divided, take away 68 would give you this and this. Yep, you could have divided it by 2, which would give you this bit in green and this bit in green, and then added 34 to that. Now, I'm going to simplify all this. I was just trying to show you that and say like you could do all this if you wanted to, or you can memorize these numbers now. You can memorize the numbers for each individual area. So these are obviously 34, 34. The next one's going to be 13 and a half, 13 and a half. The next one's 2.35, 2.35. The last one is 0.15, 0.15. So what you want to remember is 34, 13 and a half, 2.35, 0.15. So if I asked you now, yeah, it's always going to be the same numbers, so you might as well memorize them. So if I ask you what percentage of students got scores between 20 and 26, now you would just go, oh yeah, 34 plus 13 and a half. What percentage of students got between 14 and 26? Yes, you could have added them all up, but if you know that's just 2 standard deviations, well, that's just 95%. So it's up to you. You either do it the longer way or you learn the individual areas. Most of my top students in standard maths just learn the individual areas because there's only 4 of them anyways. All good?
Yeah.
All right. And last one, z-scores. That's what you need to know for normal distribution. And then z-scores. Z-scores, the formula is this. X is your score. This is your mean or your average. And obviously this is your standard deviation. The lower the z-score, the closer, the lower the z-score, the closer to the mean you are. Depends. Who wants a lower z-score? Maybe your teachers. Your teachers will want lower z-scores, then that means their whole class is consistent. They've all got the same mark. Yeah. But you as a student, you probably want a higher z-score. So that means you're further away from the average, and you want the z-score to be positive, obviously, not negative. That means you're further away. Yeah. All right. So technically, when I told you here you're 1 standard deviation away, that also means you're 1 z-score away. That's plus 1 z-score. That's 2 standard, 2 z. Your z-score is 2. Z-score is 3. Z-score is minus 1, minus 2, minus 3. All good. And then the math, the algebra, no one has a problem with. If I gave you z is 2, and if I said x is unknown, I gave you the average is 20, and I said standard deviation is 5, I'm sure we all can do 2 times 5, which is 10, plus 20, and find my score becoming 30. Do you know what I'm saying? Like, that's just simple algebra, or simple equation work, whatever. So, without overcomplicating this, let's have a look at questions now. Let's find one. I'm pretty sure I saw one before.
Honestly, like finding it is easy when you know the formula, but it's just remembering all the formulas for one topic is what like ruins it.
I know, but you know what I say about that? Like, you repeat it 5, 10, 15, 20 times. If you write it just like you've written your name and you've written quadratic formulas and like you've memorized, your brain is very powerful. You're memorizing your speech right now. It's very powerful. Just do it. Just do it. Fred sits his trial exam in modern history and ancient history. The marks for modern history have a mean standard deviation of. The marks for ancient history have a mean and a standard deviation of 2.1. Compare and contrast the distribution of marks for the 2 classes. Well, modern history, lower mean. Ancient history, higher mean. Obviously. Modern history, lower standard deviation. Ancient history, higher standard deviation. 1 mark for that. But so what? So what? You've said, you probably stated the obvious. So now you've got to say, even though modern history, why do I MD? I don't even know. Anyways, MH, even though modern history, what am I trying to get to? Even though modern history had a lower mean, finish the sentence for me.
Higher standard deviation. Oh, wait.
No, it had a lower standard deviation.
Lower.
No, it had a higher one, didn't it? Oh, that changes my conclusion. Sorry. Higher. Okay, no, it's not even though. Yep, go back. Sorry, let's start again. Ancient history. Go ahead. What were you going to say?
Its results more spread out.
No, actually, it's got a lower standard. Yeah, ancient history has a more,
So consistent.
yeah, consistent
And then modern history has more spread out, I suppose.
marks. Has
Variation,
more-
more variation.
Yeah, whereas modern history has a larger variation.
Yeah.
If it was the other way around, the way I was writing it before, I was going to say even though modern history had a lower mean,
Yeah.
but because it had a lower standard deviation, that means it was even more consistent.
Yeah.
So that's good.
Yeah.
Depends on how you see it. Like if it's from a teacher's point of view, that means everybody did the same,
Yeah.
which is good. But anyways, and then Fred scored 65, so that's his score for modern and ancient.
Wouldn't they want like a higher mean and a lower standard deviation?
Wait, say it again. Don't they want a higher mean?
And a lower standard?
Yeah, of course.
They would, yeah, right?
Which is what happened.
Yeah. And like, I mean, because.
From the teacher's point of view?
Yeah.
Yeah, of course. What I meant by, I was talking about the lower one specifically. So if you're going to get a lower mean, if you're going to get a lower average, you don't want a lower average with a higher standard deviation.
Yeah.
You actually want a lower mean
With that.
with a lower standard deviation. Wait, you want that only because that means you're consistent.
Yeah.
If you didn't have that, that means, hey, great, you taught 5 of those people really well, and then you taught 5 of those people really bad, and then you just taught the average. Like,
Yeah.
so it depends what you're looking for. If you're looking for consistency, yeah, you want.
I think our maths class is like that.
Yeah, it just depends. Like, all right.
Lower mean and lower standard deviation.
Yeah, that's the one. All right, 80 for ancient history. That's your score for ancient. All right, using z-scores, explain which subject he performed better in and why. So let's see. Z-score for modern, Z-score for ancient. Does anyone remember the formula?
X minus the mean
Yep.
over the standard deviation.
That's it. And then for ancient, it would be 80, take away the average over 2.1. All right. And what did we say? You want a lower Z-score or a higher Z-score for Fred?
Higher Z score.
No.
Lower.
Oh no, lower Z score. Higher.
Wait. No, maybe you were right. Hold on. I'm typing and I'm thinking at the same time. All right, 1.90. For Fred, does Fred want a high Z-score? Well, okay, hold on. So Fred got 1.96. Actually, yeah, okay, I can tell you the answer. You weren't wrong the first time. Fred wants to be further away from the average, doesn't he?
Yeah, doesn't that mean he's higher ranked if he's higher? The
Yeah,
higher.
so he actually did better in modern than he did in ancient. Oh, yeah, no. He did better in modern than he did in ancient. Do we get why he's done better in modern than he did in ancient?
Yeah, because
He's further away. He's further away from the average than he was in ancient.
yeah.
Yeah. But that's also because it's a higher Z score. So Fred wants a higher Z score.
Yeah.
A teacher wants a lower Z score for consistency.
Yeah.
Good. Okay, we'll stop it there.